Let me show you how to find the orthogonal projection of a vector onto another using the dot product. So here's what we want to do. We have a vector A and we have a vector B, and I want to find this vector right here, which is the orthogonal projection of B onto A. Here's how we do it. If I have a vector A and a vector B, the orthogonal projection will be a vector that is in the direction of A and of this length. If the angle between A and B is theta, then by trigonometry, this length will be the length of B times the cosine of theta, but that quantity appears in the formula of the dot product. The dot product of A and B is the length of A times the length of B times the cosine of theta, so this length is precisely the length of the projection that I want to find. So if I solve for this in this formula, then what I get is a formula for the projection, for the length of the projection of B onto A is the dot product of A and B divided by the length of A. Now, this is the length, but I want an actual vector. So what is that vector? Is a vector in the direction of A of this length. Now, what I need is a unit vector in this direction. So a unit vector in here, in this direction, will be given by A divided by the length of A. So the vector that I want will be this vector, which is this vector, the unit vector, times scaled by this multiple. The result is that the vector, the projection of B onto A, is given by, well, the unit vector in the direction of A is scaled by the factor, the dot product of A and B, divided by the length of A. If I put this number over here, then what I get is that the projection is given by A, is scaled by the dot product of A and B, divided by the length of A squared. So here's an example. Let's find the projection of the vector B onto the vector A. So the vector B in the direction of A. Here a sketch of where is A, where is B, and the orthogonal projection is this little piece of a vector right there in the direction of A. So I'm going to use the formula. The projection of B onto A is given by this formula. So let's figure out what is the dot product. The dot product of A and B is 1 times 0, 0, plus 1 times 1, 1, plus 0 times 1, 0. So the dot product is just 1. What is the length of A? It will be the square root of 1 squared plus 1 squared. So it's the square root of 2 squared. That cancels the square root, so I just get a half times A. That's A. So scale A by a half. So the answer will be a half, 0. And you see that it is a vector in the direction of A, but just a little shorter. So that is the right answer.